Okay. Should we start? Please take a seat, and in fact, for those who are sitting in the back, feel free to come a little bit closer. We will engage with the audience. We will take questions from the audience, so you're very, very welcome to come a little closer. Welcome back for this session that is going to look at the next generation of research infrastructures. This session is sponsored by the European Synchrotron Radiation Facility, otherwise known as ESRF, located in Grenoble. And the purpose of this session is, well, let's say there are two main purposes. We're going to showcase a project that is STREAMLINE, but I won't spoil any of what the project is about because they are much better advocates than I am to talk about it, but we're going to talk about the cool stuff that is happening in research infrastructures. And we're also going to explore how this cool stuff is not only cool, it can actually be a game changer to help solve the challenges that industry is facing, but also challenging for the benefit of society. So we have an hour in front of us. The way we're going to proceed is that we're going to hear two little presentations to start with. One about the STREAMLINE project by a user of this of the project, and then we'll move on to EMBL, but Edith, I'll introduce you properly afterwards. And then we'll have a little panel discussion, during which I'll come to you, okay? So this is the next this is the research infrastructures focused session. We are going to get some fresh ideas to bring also to the plenary sessions in the afternoon. Bernd, I'm going to hand over to you. So you're Bernd, okay, Hinrichsen. How is that?
Perfect.
You're very kind. This is not true. But you're Chief Executive Officer and co-founder of Momentum Transfer. Welcome, and we'll let you kick off the presentation.
Okay, thank you very much. You can all hear me, right? Wonderful, and it's a great honor to be here. I'm very excited because STREAMLINE's changed my life. Yeah, that's absolutely true. And I'm going to tell you the story about how it happened. Yeah. And it has been really exciting. It is a story of how a huge industry, yeah, the chemical industry and BASF, and me being a part of BASF for many, many, many years, running a lot of their analytics, came together with the ESRF under STREAMLINE and produced something spectacular. Yeah? And if I could have the first slide, I could get on with it even better. Do I have to do it? Oh, goodness. Okay, thank you. All my fault, as usual. There we go. There we go. Wonderful. Okay, so this is all about synchrotrons, high throughput, X-ray scattering. That's been my life ever since I did a PhD. X-ray scattering is a wonderful tool. It can give you exceptional insight into the structure of materials, and you'll also hear something about that from Edith later in EMBL talk, right? What happened, I was working at BASF doing a lot of battery research as well, or analyzing batteries, because I was running the diffraction and electron microscopy units at BASF in the central labs. We had a big challenge, came to ESRF. ESRF had this brilliant program that was sponsored by the EU, STREAMLINE, and we used part of the STREAMLINE money to develop something that has turned into Momentum Transfer, the company that we just founded, and which is going to change the way materials are characterized forever. So, what was the challenge that we faced at BASF? We were developing high-throughput battery material synthesis, yeah? And this was to get hold of the best material for the development of battery materials, right? So when you're in the development phase of battery materials, you have to go through a huge parameter space of recipes, basically. You know, you want to figure out the right temperatures to cook your materials at. You want to figure out the right dopants to put in. And all of those have quite a fundamental effect on your materials. So you want to make sure that when you put that recipe into your 100 million euro factory, it's going to produce the best material. And that's why we parallelize these synthesis routes. And the result is we're getting thousands of samples out every week. Yeah? And that is a challenge to characterize. And this is the challenge that is not only facing industry, but is also becoming quite fashionable in academia, right? Automated laboratories fed by AI synthesis routines. Yeah? Those are the things that are being built nowadays. And this is an example of one of the later publications that I came across from December last year, where the colleagues in California built this robot to synthesize a huge number of potentially new materials and then characterize them as well. Yeah? This is our solution. It looks quite dinky, yeah, but it is really cool. Yeah, we've got very small sample amounts. You see my finger on the top left of that picture. We've got small samples. They're put into small sample holders. There are 16 sample holders. That's just a unit of our high throughput system for the synthesis, and each of them gets their own code. Yeah. We've even got a second version of that because we realized once we had a hot, humid summer that the previous version did sort of was rather permeable to water and oxygen. So we've developed a new version which will hopefully solve all of those issues. Yeah? And what happens to them? They get fed into a sample changer. Yeah? And this sample changer exposes one sample to the brilliant X-rays of the ESRF EBS rays, and reads the QR code and goes off to the next sample. Yeah? And all of that in 1/10 of a second. Yeah? So it's a really snappy system. And then it produces data, and the data were mind-boggling. Yeah? I've been doing this type of science for a long time, and this was absolutely beautiful. Yeah? The resolution of the peaks was impeccable. The noise level was undetectable, basically, and the speed was phenomenal. Right? So we got absolutely fantastic data, which is out of this world. Yeah? But that's what you expect from the ESRF, right? You always expect fantastic data. You don't go there because you just want sort of okay data. And what is phenomenal about this thing is the scalability of it. Yeah? Now, to just give you an idea of what this means, I've looked at the laboratory X-ray diffraction world. Yeah? I've worked in that industry as well, and I know it quite well. And this is how it's developed since its inception in 1917, first X-ray powder diffraction experiment. And this is the number of lab instruments, yeah, that are currently active around the world. And today, in 2024, we have roughly about 12,000 instruments, very unevenly spread across the world, but active today. And if you're very generous, you can say that they could have a capacity of about 1,000 samples every year. So that would end up at about roughly 12 million samples a year. Now take this value and compare it to that one beamline at the ESRF. One synchrotron, one beamline can produce more, or can measure more samples than all of the laboratory instruments in the world combined. That is phenomenal scale. And that is the basic business case that I saw for momentum transfer. We are going to make this available to the world. And we love open science, yeah? And we're very invested in making this capacity and this brilliant data available to everyone and everywhere. We want to make the understanding of the data also more easy, and that's why we're building a data analysis platform now with talented coders. And finally, we will enable AI materials development by coupling the data analysis with AI algorithms and making that available also to these autonomous laboratories. And I'm all doing this with my co-founder, Max. And this is Momentum Transfer, and I thank you very much for your attention.
Thank you, Bernd. I understand why you were selected to present the project. I do have a few questions for you, but I'll do that after. I'll let Edith introduce your part, and then plenty, because you raised a number of very important points. So we now hear from Edith, who is the Director General of the European Molecular Biology Laboratory. Edith, over to you. Thank you.
Thank you. So it's also a great honor and pleasure for me to be here. I realize that indeed this is a session that truly celebrates the power of infrastructures in science. So maybe just to start by saying, before I use my slides, EMBL and ESRF go back a long way. Before ESRF was even, open to public. In fact, that co-location and that synergy of trying to see how synchrotron radiation could be useful for biology and for biological research has led to what I would say many people currently consider a true revolution in the life sciences. The data that was generated thanks to using X-ray and synchrotron approaches for structural biology in this very close collaboration and partnership between ESRF and EMBL and other partners on the EPN campus led to the wealth of protein structure data that the world has. I mean, obviously other sites also contributed, but it was these structures combined with the storage of the protein sequence data that another part of EMBL, the EBI, hosted, that led to the development of AlphaFold. This is an AI tool that has now been used millions of times to predict protein structures. And it was thanks to that drive of research combined with large infrastructure that this dream came true. So now I will come back and give you a few glimpses of what EMBL and ESRF have done, but more importantly, what we're going to continue doing together. So this is EMBL in a nutshell, one slide, to show you that we are, I think, Europe's unique life sciences research organization, intergovernmental organization. And I think what is very special about us is that we do research. We actually conduct research across our 6 sites in 5 different host countries, including France and Germany and the UK. But we also deliver services. And in fact, EMBL Grenoble and ESRF illustrate this very well, how research and service really go together and provide access to infrastructures. We also deliver training at many levels. We train the young scientists, the generation of tomorrow, but we also train all of our users, and people from all our member states and across the world come and participate in our courses and conferences that we organize every year and that constantly evolve. We do innovation and translation. Thanks to the research we do, the technologies that we develop, we end up creating some of the tools that the world uses. And we generate spin-offs, and actually EMBL Grenoble together with the SRF is a beautiful example of that, where we develop the robotics and the automation that are necessary to allow users to have reproducible and easy access to these advanced technologies and infrastructures. And last but not least, we are here to integrate the life sciences. We provide the glue that is so important, particularly in times like this, where geopolitical uncertainties are rife. We actually allow scientists to come together. And I think this is, again, the power of these infrastructures, is to bring scientists, allow them to collaborate, develop new resources, new tools, and train the next generation. So some some numbers at the bottom, but I don't want to dwell more on EMBL alone. I want to say that this is, for me, the perfect example of how research infrastructures can partner up together to advance the life sciences. And today, ESRF, as I'm sure we all know, is the world's brightest synchrotron light source. It produces the most brilliant X-ray beams in the world. This is something that we should all be proud of and that we should be investing in. And with EMBL as one of its key partners, we can go from crystals to visualize molecules and develop the next cutting-edge technologies and make the discoveries that the world needs. And the research that we do, and I should say EMBL is in the midst of a brand new program from molecules to ecosystems. So the research that we do that feeds into this service is not just about discovering great science, it's also about how to apply it. So we're rising up to societal challenges, be they human health or planetary health. And if I had another hour, I could tell you even more about that, but I won't. So just to say that indeed scientists from all over the world come to Grenoble, to the ESRF and EMBL in order to do their cutting-edge research in the life sciences and to innovate. And so this is just a historical slide. I'm not going to go through it, but we go back a long time. You can see these old 70s shots with people in sort of strange clothes and yeah. But you know, those were the good old days, right? And that's where it all began. And this kind of close collaboration, realizing the power of a synchrotron and all it could provide for biology was compelling. And very quickly, EMBL and ESRF, together with the ILL, realized that we could develop some of the technologies that would be needed for people around the world to be able to work with synchrotrons. So this actually culminated in the signing or the creation of the Joint Structural Biology Group. And today, this is stronger than ever before, I would say, because with the fourth generation of beamlines and the brilliance of the light that we get at ESRF, this upgrade has meant that we can start to see many, many more applications and technologies than we'd ever imagined, in particular in areas like X-ray imaging. So here, I just want to show you 3 impacts to illustrate how versatile infrastructures can be. Whatever you hit them with, they can rise up to the challenge. That's why I think we need to think about the sustainability of these infrastructures. So when the pandemic hit, what happened? Well, the infrastructures rose up to it. EMBL and ESRF together, the Massive 1 beamline was used extensively by the global community to work out how SARS-CoV-2 virus proteins worked and develop new drugs. And this was something that we were able to do even without, I mean, I know, AI and robotics are currently very, very fashionable, but actually EMBL and ESRF have been doing this for quite a long time, which meant that during the pandemic, we didn't even need to have necessarily people on site. We were able to continue delivering the services for users around the world, as far as the other side of the world. We also have joined forces in terms of pharmaceutical discovery, and we're partners in a Horizon Europe-funded fragment screen project, which is bringing some of the much-needed expertise in X-ray fragment screening, and this has been, or is currently, an enormous success and opportunity. And last but not least, in terms of sustainability, which is something that many organizations are thinking about, EMBL ESRF beamlines are being used currently to advance planetary health in a way where we can actually recycle PET plastics. And this is something that I think we all understand. We've almost left too late, but now it is something that is being addressed actively thanks to the combination of EMBL and ESRF together. And I want to say this is my ultimate slide, my last slide, but this is the future. EMBL is actually celebrating 50 years this year. Our partnership with the ESRF goes back from the very beginning. And yet, I would say that some of the projects that we're planning now are more exciting than ever before. On the one hand, we're setting up and operating the beamline for time-resolved macromolecular crystallography and small-angle X-ray scattering, as ever, but to go for 4D structural biology. AlphaFold is a true accelerator. So now we can take that one step beyond and truly test some of the hypotheses when it comes to protein structures and how they behave under different conditions with respect to drugs or with respect to environmental changes. This is another brand new project that will be launched now, nano X-ray imaging. This is cutting edge nano X-ray imaging with a beamline at 10 to 15 nanometer resolution. This is going to be another revolution that will allow us to visualize not just cells and tissues, but molecules and organelles. So these building blocks of life we will be able to attack thanks to this new project with the ESRF. And we're going to expand our beamline accessibility with ESRF. So these are automated, user-friendly approaches. These are huge infrastructures, but we're making it easy for people to be able to come and test their favorite hypothesis, or for industries to come and explore what kinds of drugs need to be developed with the appropriate information on protein structures. And last but not least, we are an innovation camp on an innovation campus. So EMBL and ESRF are key partners in the giant innovation campus in Grenoble with 6 others. And this is something that the city has completely taken on board. This is a thriving entrepreneurial ecosystem with much excitement and ambition to bring industry to the campus, but also to profit from the spin-offs that are coming out of it. So with that, I will stop, and thank you very much, and just like to celebrate ESRF and EMBL.
Thank you. Do stay on stage. Bernd, do you want to come up? And may I ask the other 3 speakers that I'm going to introduce? You seem to know where to sit, so that's very good. So next to Edith and Bernd, we are joined by Michael Arentoff, who is the head of unit for open access and research infrastructures at DG Research and Innovation, European Commission. Marie-Ingrid Richard, scientific researchers at CEA, CEA, and visiting scientist at ESRF. And finally, Michael Krisch, the interim director of research for life sciences, chemistry, and soft matter science at ESRF. Welcome, and thank you for joining us. We're going to talk about the future. But before that, Michael, educate people like me, ignorant in research infrastructures. We've heard from Bernd what the STREAMLINE project is about, but can you just to set the scene once again about the STREAMLINE project and the next generation of research infrastructures? What is the upgrade of ESRF's extremely brilliant source about?
In a nutshell.
In a nutshell, what does it allow? What does it allow next? What are the experiments?
Spontaneously saying, I think it was a great adventure, a tremendous effort of the entire community of the ESRF, supporting the ESRF, the 21 partner countries, and I would say, what we've heard so far, likely a success story. But what is it really? It's a long thought-through process and program that started in 2029 and terminated 31st of December 2023. 2 phases. The heart piece of that program was a brand new, revolutionary electron storage ring that had only a sole purpose: to produce the most brilliant synchrotron X-rays in the world. And that was built with 90% of the existing infrastructure in a very cost-effective manner, even saving energy in the end. But it's not only about the tool and the X-rays, it's about the experimental exploitation of which you could just got the very surface of it. We renewed or entirely built 27, almost 30 experimental stations from scratch. We augmented these capabilities of the facility by a set of support labs and support facilities. We have engaged in a very ambitious instrumentation program, quite often together with the EMBL and other partners locally and in Europe. We have engaged as well in a very aggressive data analysis and data management program that...
And we'll come to that.
And we come to that, but just to say that our ultimate aim, and this became clear from the introductions here, we need data analysis as a service to a user community that is no longer made out of geeky physicists.
Very good. What is the next cool thing that will come out of ESRF? What's these upgraded facilities? What do you picture? What do you think is going to be the next breakthrough coming out of it?
Well, the things are already coming out, because the key of success of that upgrade program was that the science program was set clearly from the very outset. Even in phase 1, where the new machine was not even in its final design, it was already anticipated what the capability would be. So what we see since the restart in 2020 is a tsunami of mind-blowing results. I mean, you touched upon some in structural biology, but the massive screening of fragments as well as materials for battery energy research and catalysis in large amounts combined to machine learning algorithms just revolutionizes the way we see the future design of relevant materials. We've seen one of the highlights of ESRF EBS, again linking to the COVID crisis, was the capability, thanks to the extreme brilliance of the light source, to image human organs down to a level in the order of 2 orders of magnitude better than the best CT scanners worldwide. And while the MX beamlines deciphered one of the enigmas of the COVID virus at a molecular level, work at the ESRF on COVID lungs allowed to unravel the vascular origin of the disease. So this is just one of the very few examples.
Thank you.
I can continue, but you stop me, as I said.
We have a researcher actually next to you. You're an ERC grantee, Ingrid.
Yes.
And you've been, you're using ESRF, right?
Yes.
So how does it help? What is your project about? I should start with that. And how does it help in your daily research?
Yes, so I had the great chance to get our ERC grants. So my project is still ongoing, and without ESRF and the EBS upgrade, it wouldn't have been possible. So what is very nice is that I can have a look at some catalysts. So there are some materials to speed up chemical reactions. So they can be used to create fertilizers, or for battery materials or other things. And due to the upgrade of ESRF, I can look at these materials in situ during operation. So X-rays, it's like a very wonderful macroscope, an X-ray macroscope, so I can see the particles when they are at work during batteries, during reaction, and I can have access to high resolution, so to look at the very small world and without damaging the materials, because I have access to some high energy owing to the EBS upgrade. So it has been a big step for the project, yes.
How often can you use the beamline? Is access to the beamline an issue?
I mean, generally, it's quite competitive to access the beamlines at ESRF and for other synchrotrons, So I had the chance with my ERC to have access to some beam time through long-term projects. So twice a semester, I can access to one of the great beamline at ESRF, and I can do my research with my team, yes.
Twice a semester?
Yes, at least, yes. Mm.
It's a general question, and maybe not that doesn't apply only to ESRF, but is accessibility to the infrastructure an issue?
Yes, absolutely. I mean, what we have seen for beamlines across research infrastructures in Europe is indeed that they are largely oversubscribed. So to give more individual grants to researchers is not the solution. It's really about capacity at the research infrastructures. And it's also increasing because we have new users coming. We were talking a lot about collaboration with industry. And indeed, this requires to look at the capacities. It requires also to look at how access is provided. It requires, first and foremost, I think, information between the two, communication between the two. We recently signed from the side of the EIC an MOU with ESRF. And this is a brilliant example of how ESRF, in this case, told potential innovators about the services that they provide. So this kind of communication is what is needed also for attracting new users and for addressing some of the problems that or challenges that we heard can be solved by having access to these facilities.
Accessibility. So you're bringing more users with this MOU from the EIC, but you already have too many. How do we solve that?
We'll cope with it. We have actually, with ESRF, EBS, and with the help of the STREAMLINE project that was entirely funded, single beneficiary, 5 million, that really supported the optimization of streamlining the science post-ESRF, EBS. We implemented new access models that are based on community access. Because as I mentioned, this is a very still increasing community. And this community access allows that people work together from the very outset, bringing together diverse expertise and use A, the facilities much more efficient, and B, since they have the combined expertise to go all the way from the sample prep to the data analysis, they speed up the path from a great idea to a scientifically relevant result. That's one way. We have as well rapid access, because some of the problems are really pressing, like the COVID crisis. We actually opened, during the lockdown of France, opened the facility for these type of experiments. And, of course, the long-term accessibility, guarantee access for ERC grantees is another concern, where despite the fact that we have a peer-reviewed external review, these people get these preferred routes into the facility. We'll cope with that, but people have to group together, and these isolated researchers that come up with one proposal, one idea, get one time, beam time. It will be a small fraction, but the community access will be making the difference, because you reach out to much more people.
Should we move on to the question of data, because this is all related? And in fact, I know we probably need an hour to talk about what to do with how to best use the data that comes out of the research infrastructures. But you all experienced data, the data challenge in your capacities. Maybe I'll start with the users. What do you think is needed to make this best use of the data? From your perspective, you've got all this mountain of data coming. And then what? Edith.
I'm not sure I consider myself as a user more than a host of big data, because we've seen how exponentially the size of data collections is increasing. And I mean, you know, it was huge for areas like astronomy, but now in the life sciences, it's enormous. So actually, since the creation of the European Bioinformatics Institute 25 years ago, the concept was truly to ensure that scientists put their data somewhere where they can trust it, where they know it's going to be properly curated, and where it's going to be made accessible. So open science is not just something we aspire to, it's something that we have to do. But to do it properly, you have to make sure that the data is indeed dealt with. And
There's a microphone issue here.
No, it's gone. No, it's back.
It's back.
So from my perspective, it is a challenge that we can tackle. We've seen it, you know, with genomics, exponential. Now with imaging, exponential. And in fact, we're getting better at storing data and sharing it in appropriate ways. And I think Europe really has an advantage here as well, because people do like to collaborate and to make sure that they come up with community ideas of how to do this. So from the perspective of the ESRF and the data challenges that are going to come there, I would say as long as the resources are there to make sure that the infrastructure can host the data, train the people who will actually be not just using the data, but also dealing with it. That is, for me, the biggest challenge, I would say. You know, the capacity is not really the problem. For me, the challenge is the people who we need to make sure that we do the appropriate checking, sharing, and develop the tools, including AI approaches, that will allow the world to benefit from the data, not just the individual user. So for me, that's one of the key things that would need careful attention, training up that next generation of scientists who will allow data to be properly dealt with.
Bernd, is it part of your services, actually, the data analysis?
Yes, absolutely. Yeah, that's something that we're currently building up, and when we build our tools, we're still using sort of the American hyperscalers, yeah, that to create what we need for the analysis. And that'd be one thing that'd be really cool if we could, get the European hyperscalers up to the same par, so that we can also have that here. But yeah, I think the data is a big topic, and it's a whole session for itself. But one thing that's happened in the past years, and I think that's fantastic development, is that data scientists have become really highly valued individuals. There used to be sort of the nerds in the back dark rooms, yeah, that hacked away, and the last 3, 4, 5 years, their value has just peaked, and it's fantastic. Yeah. Those people are the guys, are the women and the men that we need nowadays, to deal with it.
Michael, do you have any data scientists around to help researchers like Marie-Ingrid?
We actually put full blast on that. But the point is, we have limited capacity ourselves in the facility. We can have core people that act as a sort of a facilitator and multiplier, but we need external help. We need this ecosystem, this famous ecosystem that Edith was referring to, and we are particularly privileged in the Grenoble area, where we not only have 3 international research infrastructures, but we have this giant innovation campus, and the engineering and the university are part of it. So, for example, the university in Grenoble has an entire institute fully focusing on artificial intelligence and machine learning things. We have to connect with them, but we have to connect not only to the local ecosystem, we have to connect to the ecosystem of our European research infrastructures, and that's actually our strength. We are serving an entire community Europe-wide, and in Europe, all the capacity in AI, in machine learning, and in these nerds is almost infinite. That's why I think we're going to make the difference. But as a facility itself, we don't have the capacity. It's not our role, really. We can facilitate, and we have to facilitate.
Yes, I mean, you've already mentioned many of the important challenges. If I may, also what's coming up now, what we see in research is machine actionability. So you have users, human users, but you also have machines as users. And to make AI, really exploit AI, you need to make the data not only fair and of high quality, very important, of course, but also to make them machine actionable. So to put enough detail into the metadata that allows autonomous computational data exploration is becoming increasingly important, and this is something that we will, I guess, also support increasingly from the framework program.
You're already thinking about supporting?
We are already supporting activities in that direction, and probably we will accelerate that and give even more support in the last half of the current FP.
Ah, all right. But this is an important information for all the research infrastructure people in the room. So that's one for 25-27, right?
Exactly.
For the reminder.
One of the key orientations in this domain. Yes.
Very good. I want to move on to another topic, and that is also the industrial applications. And then I will turn to you for questions. So do prepare your questions, and do prepare a mic if you have one in the front, in the back. But yeah, industrial applications, the attractiveness of the research infrastructures to big companies, and the need to, well, that has also come up at the level of S3, right? The need to attract those companies, and as a revenue stream as well for research infrastructures, private investment, right? So maybe I build on your experiences first, Bernd and Marie-Ingrid. I'll start with you, Marie-Ingrid. You are a researcher. Your job is in fundamental research. Mm-hmm. However, you do work with companies, right?
Yes, I work with companies like ST Microelectronics, And it was very important to work with them and to do the collection of data and the data treatment, because they need very fast results. Because they have more cook and look approach. They are looking at a lot of samples, and to fasten the development, it's good if they know some physical mechanisms of what they are observing. Because it's difficult to screen all these materials, and with ESRF, we can screen faster materials and bring some ideas about the mechanism behind. For instance, phase change materials, integrated circuits, they have a lot of questions, yes, and we can help them, yes.
So the company come to you?
So it was an industrial long-term project with ESRF. So they came at the beamline and we helped them to find the techniques suitable for their materials, yes.
You want to name a few companies?
Yes, so it was, it was with ST Microelectronics. Now I'm working on Catalyst, and I've been approached by Toyota, for instance, by some companies, yes, to look at materials at small scale and why they are working, yes.
Very interesting. Bernd, you were with BASF before you started Momentum Transfer, right? And BASF has invested into your company.
Yes. That's true. So I'm very grateful for BASF investing into the company, but they also invest into a lot of work that does end up at synchrotrons to be characterized. Yeah? It's very varied, so there are lots of different facets. So catalysis is one, batteries are one, cement additives are another. Yeah? I mean, that doesn't just stop there. I mean, the whole microchip industry is something where synchrotrons have been playing a very fundamental role, yeah, in developing the strength of the European market. And of course, pharma is huge. Yeah? It's so synchrotrons are quite necessary for the industry to thrive within Europe. I see them as a fundamental part. Yeah.
Is it fair to say that Momentum Transfer is an intermediary between the research infrastructures and large companies?
Absolutely. We see ourselves as an intermediary between synchrotrons and companies, but not only that, we also see ourselves as an intermediary between the synchrotrons and academic users, because as you've heard, it's really challenging to get into the synchrotrons and to get in beam time. And once you're in there, making the best use of your beam time is also a challenging task. It's not trivial. And for all of those academics that haven't got that experience to apply for those type of beam times, or don't have the experience of building up an experiment and getting everything going, for those we're going to offer this service as well.
Very good, but okay, we still have one challenge to solve, is bringing companies to come and invest. We know that research infrastructures are largely publicly funded in Europe. So is it realistic to think that we're going to move towards a co-investment model, public-private?
I think in general, you cannot say, because research infrastructures across Europe are quite varied. So obviously not all of them are as attractive to industry collaboration as others. I think the light sources, definitely, and we have seen the example. The importance of...
Microphone?
Hence the importance of intermediaries, and they can be Bernd's company, they can be RTOs, as we heard in the previous session, by the way. Yeah. So that's very important, but we also see a change in the kind of support that we think should be given from the public purse. So traditionally, of course, the collaboration with industry has been as a supplier of equipment, of components, and so on. But more and more, we see the value in collaborating with industry. What we fund from the research infrastructure as part of the program is driven by the needs for technology developments of the research infrastructure. There are other parts of the program that set priorities according to the needs of industry, and we have the notion of technology infrastructures, and there's a continuum between them. And if you look at each individual infrastructure, you have to look at who are driving the beamline time, who are driving the priorities for the different research activities. So we do that case by case. We try to set priorities also, of course, following closely what's happening in the different types of research infrastructures. As I said, some are more prone to collaboration with industry, and we see benefits not only from a scientific point of view, but certainly also from an economic competitiveness perspective and also from a societal perspective.
Edith.
One example, at EMBL, I guess we attract both academic researchers and industry. And I just want to really emphasize the virtuous cycle that happens when academic research is done. It feeds into new technologies, new needs, but it also then leads to new industrial partners. And at our headquarters site in Heidelberg, for example, there's a spin-off that came out of our laboratories that was called Cellzome. This was very successful, hosted by us. It was bought out by GlaxoSmithKline, so GSK. They bought it out, and they were so enamored by working with EMBL as an infrastructure that they then built a building on our campus so that they could be close and interact with us in this virtuous cycle. So I think it's really important that that ecosystem is nurtured at all levels. You know, you need to have the research, you need to have the attractivity to industrial partners, and we need also the speed and the flexibility, and that's maybe something also to consider, that industrial partners usually don't have any time to waste, so going through lots of paperwork is not their thing. We saw it with AlphaFold. Google DeepMind came to EMBL because they knew that we would be able to deliver, not only because we had the data, but because we would be able to very quickly implement the tool that we could then share with the world. I think that speed and flexibility is absolutely key to success as well.
You agree, Michael?
I agree. Sorry, I didn't get acoustic. I agree. Nothing more to add. I think the time is over to have industry only as suppliers. This is obvious. In industry, as clients, is the background business. We have that. We're very successful with that. But co-innovation together with industry, and as Edith said, this virtual cycle where we basically, the three pillars merge together, the research infrastructures, academia and RTOs and industry, is really this way to develop cutting edge and beyond cutting edge technology is really the future. What we need for that, you have to lower the barriers. And lowering the barriers means as well that you have to speak the same language. And we've seen that with industry. Sometimes we need the synchronization phase to get really a mutual understanding. And what the other important aspect is, you need to create the environment that industry is used to at the facility. And this is really what wonderfully worked with momentum transfer and works with other clients. We have, for example, recently hosted at ESRF because another synchrotron is currently in an upgrade following ESRF. And it took a lot of time of the colleagues from the business development office to adapt specifically our beamlines to the specific needs of these clients who were used to a very well-established environment, and we needed to replicate that. But once this is done, high fidelity, high productivity, and quality assurance is key for success, I think.
Very good. Do we have questions from the audience? Oh, wow. Can I ask you to introduce yourself? And I hope the microphone is coming your way. Yes.
Hi, sorry. I'm Stefan Bergmans. I'm from the European University Association. And I'd like to jump on the last part of your discussion and what you mentioned there about the co-innovation. Because what we see currently is the trend to separate research infrastructure from technological infrastructure. I've heard that ESRI is not really happy about that, but more importantly for me, from the universities, from my members, I hear it doesn't make any sense. Because when you think about an infrastructure and the research going to the applied research, it's all one continuum. And for a university, you have that actually on campus. So I'd like to hear your views on this, because yes, I can understand how some would like to draw budget out of that. But I think it's going to bring fragmentation from what I hear, that is not going to be helpful for infrastructures, for research, and for applied research both as and basic research. So I'd love to hear your comments on this.
Very good. We can take another question. There are two more, so let's take the three and then we bundle them.
Thank you, Mr. Chairman. Good morning, citizens. My name is Angelos Harlaftis, Epafos Advisors. We represent always the EcoWaves movement, the scientific part of ours. We are based in direct democracy, in science, and in ecology for all Europeans and Mediterraneans. We are speaking for a lot of years about the creation of the CNET, the European Internet, which will give us the proper direction for the scientific autonomy of Europe against the globalists' ideas, which they will not, and they don't want to give us a kind of autonomy, but a kind of not independence for us. Thank you very much.
And one more, here.
I'm Martin Adler from the Initiative for Science in Europe. I have two small questions. One is, how do you deal with the security issues in the infrastructures, access for foreign researchers from unfriendly countries to the infrastructures that you organize? And the second question is more going the other way around. You have specific programs to allow researchers from so-called widening countries to have access to their infrastructures.
Who goes first?
I could
Please.
make an attempt for the first one. As I said before, we also see it as a continuum between research and technology infrastructures. And what matters is what is driving the priorities. So we see a European added value in supporting common technology developments when this needs comes from the research infrastructures in the research infrastructure part. But as also you hinted at in your question, Stefan, there is the possibility also to get other funding sources from within the program to fund the parts of infrastructures that also deal with needs from industry. So Cluster 4 is an obvious example. There was the Open Innovation pilot lines,
yeah.
Which is another source to extract from. We are collaborating, of course, closely across the framework program to make sure that this fragmentation does not happen and that there are appropriate references across.
So this is a recommendation for FP10, actually.
Yeah,
right?
it's already happening in Horizon Europe, but we will certainly strengthen this in the future and to make sure that indeed we do not fragment what is the reality on the ground.
How do you deal, sorry, I'll just follow up on that because research infrastructures are under the first pillar right now.
It's a very good remark. Indeed, today on the research infrastructures, we are in the first pillar. We support concept design studies. We support some of the initial implementation stages of research infrastructures, transnational access, and then these common technology developments. But of course, all of that serves both fundamentals research all the way to applied research. And we have seen examples, we mentioned the MOU with EIC in the third pillar. We know that research infrastructures are one of the the highest beneficiaries of Marie Curie actions as well. There's a lot of training taking place also. So today it's placed in pillar 1, but really it's a capacity for activities across the framework program, not only in pillar 2 to support the, if you like, mainstream research, but also very much on the innovation side and as it is placed now on the basic science side. So it's a very good remark and something to think about for the design of FP10.
Do any of you want to address the other question, maybe the one about widening security?
I can't really address it, but I think security is absolutely something that all of us are aware of, and actually maybe my colleagues can say a bit more. I wanted to just say a word about the widening, because at EMBL we have been always very supportive and nurturing of widening actions. But indeed, the challenge is how do we allow people to have access to these infrastructures, at long distance. And I think if we want to be a fair Europe, we need to really consider this, and there have to be sustainable programs that allow people to come either just as users or to get trained up. And this is something that I really think is a challenge right now. And we're all very worried about how we can make sure the best science gets done by some of these countries who don't necessarily have easy access. Yeah. So it's not really an answer, but an increase in the question.
Maybe I can echo that. I think it is our duty to really reach out beyond the partner countries that financially support us.
I don't think the mic is on.
And
Go ahead.
As an international research infrastructure, as sort of the big fish in the pond, this reaching out to countries that are not part of the club yet, I think is crucial to increase capacity in that countries who have an enormous development potential. And their European Commission has been crucial. We have been supporting, for example, the synchrotron project in Jordan through a set of European projects that were entirely designed to not colonialize them and get the brightest minds out of Germany into Europe, but just the opposite. Help as a European consortium to train these people to really run the facility on their own, in a success with their own ecosystem, with their own science program, and I think this has to continue. Then on the downside, open data, open science is of course make it more vulnerable to attacks. And the last 2-3 years have been seen devastating attacks, successful attacks to research infrastructures. But the only way is increase awareness and raise the barriers, and at ESRF we've done that, double authentication, siloing single task computers and not mixing up, looking on the web page, order your next vacation and run the control of the machine on the same computer. This is something we have been taken seriously, and we could see from the records that despite numerous attacks, we could stop them at a very early moment. But it cannot impact on our open science and open data policy. It can't.
All right. We have 2-3 more minutes, and I want to ask you, what do we do next? We've started the discussion. There were already some clear directions for the needs maybe to make research infrastructures more transversal to the program. What else? Don't we have a budget issue as well? When I was looking back, I found out that the budget allocated to research infrastructures isn't really moving. It's pretty static across the FPs. How do we make that change? Do we need it to change?
Well, first of all, I think we need to sell research infrastructures really as a strategic asset. Plenty of arguments were given. The case of the pandemic is an obvious one. The capabilities to adapt, the capabilities to do specialized services, the ability to do quick access for industry, because they have different expectations for admin procedures or simply the speed, as you pointed out. This is something we need to play on. Obviously also to play on the fact that research infrastructures serve everything from fundamental to applied research to innovation. Again, is something that speaks to the decision makers when it comes to budget, because that's what you mentioned. This is something where we have to pitch better. I think the importance of research infrastructures for the next financial framework and also for the next framework program. You mentioned if there are additional things that we need to look for. Yes, the access. So one thing is that we do need to care about widening countries. We do need to care about also access to facilities from outside Europe. But there's the capacity that we have at hand now. So maybe we should also think of other ways of accessing on a more continuous, on a more sustainable basis. We know, of course, that there's more virtual access possibilities now. There's more combined hybrid access modes. So this is something we're also looking into, have a new access scheme also for different types of users.
Final recommendations.
I said it already, but I'll say it again. I think if we don't invest in training the next generation, not just in, using data, but actually handling it at every level, the whole life cycle of data, we're going to rapidly run into problems. So for me, that is an absolute must, and we can see it. Everyone we talk to who's dreaming of AI approaches is saying, but we simply don't have enough trained up people to do this. So I think, for me, that's one of the bottlenecks that we've got to get through.
Very good. Bernd, do you have any final recommendation?
Well, I think the sort of carrying on with the path of nurturing this ecosystem of innovation on these large campuses, that's something that we just have to keep on doing and developing and creating, being better at. Of course, I agree completely with the training and our youth.
Training. Very good, Marie-Ingrid. You're very embedded in a very particular ecosystem that is Grenoble.
Yes.
There are other places like this, but not that many across Europe. So.
Yes. And I really agree. I mean, it's a good, now we can collect a lot of data, but data analysis is the bottleneck.
Yeah.
I mean, maybe we need some research joint institutes working together on AI or mathematics. Yes, so it's also quite important. And training of new people, yes, to build a team, to have PhD students, postdocs. Yes, this is very important.
Very good. Michael, the last words are yours. What do you want to take
Everything
away?
has been said.
Okay.
I think the key is young generation of people who are hungry for science, hungry for discovery, hungry to help to prepare a better future. I think this is it's the blood and it's the brain and this is the future of the research infrastructures, are the young people, and they come, and this links to the gentleman in the back, they come from academia. We all started studying at one point. We all started to go to school. We have to start there. That's where the young generation comes. And they have to come to the facilities and they have to do research. That would
Very
be the
good.
best.
Thank you. Fantastic final word. Please join me in thanking the speakers. Thank you. And thank you to ESRF for triggering this very inspiring, important discussion. Time for lunch. Thank you.
Show